In this illustration, we'll analyze the photocurrent in a discharge tube. Here we are given that in an experiment on photoelectric effect, a light of wavelength 4000 angstrom is incident on a cesium plate at a rate of 5 watt. It is saying the potential of collector plate is made sufficiently positive so that current in discharge tube attains its saturation value. And if on an average out of every 10 to the power 6 photons, one photoelectron is ejected, we are required to find the photocurrent in the discharge tube. Here in solution, first we can calculate the total number of photons in light beam. Then the total number of photons in the light beam, obviously we are calculating per second, which are incident on the surface. This will be P lambda by Hc. We calculate the value power as 5 multiplied by, here the light wavelength is 4000 angstrom, so this 4000 into 10 to the power minus 10 divided by 6.63 into 10 to the power minus 34 and multiplied by 3 into 10 to the power 8. On simplifying, this is giving us 10 to the power 19 photons per second are falling in the light beam. And we are given that out of every 10 to the power 6 photons, one electron is ejected. So here we can calculate the number of ejected electrons per second. This can be given as total number of photons divided by 10 to the power 6. So as out of 10 to the power 6, 1 is ejected. So from 10 to the power 19 photons, this by 10 to the power 6 electrons will be ejected. That will be 10 to the power 19 by 10 to the power 6 is equals to 10 to the power 13 electrons per second. Now we can directly calculate the photocurrent, which is the charge per second. We can write it charge emitted per second is the photocurrent. This photocurrent can be written as number of electrons per second multiplied by charge of electron, that is E. So we substitute the value. This is 10 to the power 13 multiplied by 1.6 into 10 to the power minus 19, which gives us 1.6 multiplied by 10 to the power minus 6 ampere, or it is 1.6 microampere. That is the result of this problem.